right into the code. We'll start with the initialization here. There we go. So I import the math module because I'm going to be doing some stuff with sine later down here with radians and the sine function to make some things work a little easier. Let's see, I set the screen size to 4000 by 4000. That way we can scroll around on the screen if the shape is too big. It's really just for scaling. I have the speed for the turtles set to 0 right now, just to show the animation of them drawing it, but otherwise I'd have it set to turtle.tracer just to make it go fast. And there's 3 turtles because the more complex design just seemed a little easier to do it with 3 turtles than programming one to kind of go all over the screen. So first design, P12. This one was pretty straightforward. So I started by making a triangle helper function. Called it triangle 1 because I have another triangle function later on in the code. Same with square 1 over here, but either way. I set the pen size to 0.02 times size, so that way it scales how I want it to with the size of the final coaster. And let's see here. I realized right off the bat that it was a right angle triangle over here, so I used the Pythagorean Theorem, and I set it to half the size, because size would be this whole thing. So oh yeah, because this is the length of the size, and then it would be half because it's not equilateral. Worked out perfectly. So yeah, just standard triangle function. I didn't do a for loop because the angles are all different. Seemed like it would work out a little better that way. And then I have 2 square helper functions here for this design. This helper function here does this design using a Boolean. So it starts off here, or rather this one. It starts off here, and I set the counter equal to 1. So in a for loop with a range of 4, if the counter is equal to 1, meaning the first time it draws the triangle, it will fill it with white, just like this. So 1, fill with white, and then this would fill with black later on in the code in the bottom. I put that in there that it fills with black, so white, black, white, black. And then this one, square 2, would be this one where if it's 2 or 4, so this is 2 right here, and this is 4. 1, 2, 3, 4. Then that would fill it with white. And I set these to white because that's always going to be white. And so the background doesn't come through later on in the final design just because of the way I put it together. And then the thing that's going to change in the inverse color is going to be this black. It's going to be black in the normal design and then gray for the grout, which you don't see here, but it pops up in the final design. That becomes the fill color, and the outline becomes black. So that's how I'm going to do my inverse. So that's why I just set it to white on both these squares, because that's not going to change, nor the orientation of the white squares. The white triangles is going to change either. So I figured I'd save myself a headache and just program in 2 rows separately instead of playing around with booleans or anything like that in this case. So I have my square row 1, and then right here square row 2. So the idea is the turtle is going to start down at this right here in this left center, draw this, come back, reorientate itself a little bit, and then draw this down here. So that's this right here, the draw P12 design. So I started off by setting the position or rather getting the position and setting it to x comma y. So that would be this point right here, and then it does this entire design, and then it goes back to xy right there. Then it does turn right 90, comes down forward size, sets up over here, and then does the second row. And that way we get this design. Moving on to design P37. Again, I do the Pythagorean Theorem, but here I do it a little different. I set the variables to a and b, and I set that equal to c, and I return c, just to make my life a little easier over here, for example. So, for example, this triangle would be referring to these brown triangles right here. 1, 2, 3, 4. But either way, the way I made this design is I did one quadrant at a time, so technically it would be this triangle and this triangle right here. And I decided to give it a 0.2 size, just because it seemed on the design sheet that it was about a quarter of the length of the entire side of one given quadrant. So that's just my that's just the triangle function for there. That's also the reason why in the previous design up here I gave it triangle 1, is because this one right here is a triangle. And so yeah, here's where I set the color. The turtle color and turtle color 2 being the fill. And yeah, so moving on to the rectangle portion, that would be this bar right here. This one I needed to do a little math with, play around. So the width of it right here would be equal to the width of this triangle, which I got using Pythagorean right here. This t dot forward Pythag size tells the turtle this length right here. So I did the same thing here, except I did 0.2 because here size equals 0.2 size. So just 0.2 size, same thing to get the width. And then I needed to figure out the height of this triangle. So this is where the math module comes in, and did math.radians 45 to convert the angle, this 90-degree angle, because we cut in half, so it's 45 degrees converted to radians because the sine function requires radians to work. And then I set the height of the triangle to height. So this right here would give me the height, and I made it equal to height. And then triangle height, I took that and I multiplied it by 0.2 sides to make everything work out a little bit better. And then to get the length of this rectangle, I took this right here, essentially, and then I subtracted 2 triangles from it, and that gave me this rectangle right here. Perfect fit. And then just a simple for loop to make the rectangle shape. And moving on to the diamond, this was just one diamond at a time, so it's these elements right here. I made the turtle just, this is the helper function, to just draw one. And then the diamond arrow would be these two put together. So here you can see the diamond color. First one is going to be this lighter brown, and then the second one is going to be this dark brown. And I used a hex calculator to get these values on Google, just so that way I could customize the colors so they are more accurate with the original designs. So this square function right here, this is the background quadrant, the background gray quadrant. So again, there's color right here, that's going to be the pen color, but I set the pen size to 0, so that's kind of arbitrary. And then the fill color right here, again, just simple, begin fill, end fill, and a for loop in the middle of that. So this is where really most of the work happens right here is this helper function, draw a quadrant, which puts all of these different elements together into a single quadrant like that. And so here, again, I took this this right here, and I put it down here, again, just so it's all in the same function. And then I rounded it to 10 decimal places to get it as accurate as possible because I was having some issues with formatting. And so here I draw the gray square using third turtle. Using the second turtle, I draw these triangles and this rectangle. And then using the first turtle, I draw these diamond arrows right here. And so here's the top level function for P37. So I just set my counter to 0 because my turtle starts here in the center. And then we start off by drawing the quadrant, which does all that. And then I bring all the turtles home right there. And then I do, so 0 plus 90, that it turns the turtles right. So orientate them this way, then they draw this quadrant, and then I add 90. So next time they come around, they turn 90 plus 90, draws this one, and then again they add 90, so last final time it adds 3 90s, comes around and draws this one right here. Oh, this one, yeah, because it draws this one first, turns here, draws this one, and then the last time around draws this one right here. And so for the inverse color, design P37, the inverse color, pretty much the same thing. I just changed these hex values over here. So here triangle, yeah, so the triangles stay the same. What it is, I changed the background colors, these two diamond colors. So I changed the grays and the light browns, essentially. So you can see here on the diamonds, I changed right there. That would be gray. And then on the square, I changed, again, to gray right there. Or sorry, to brown. It's just a gray outline. So you see it a little easier. And then triangles I kept the same. The rectangle I changed right there, the fill color. And again, the outline here would have been light brown, but the pen size is set to 0. And even if it wasn't, it would disappear because of the color of the background. And otherwise, the same thing. But in this case, I had to change the top level function for drawing it, just because this design, whereas P37, the normal color is at the top of the coaster, and I'll show this later when I actually get to the coaster. Actually, yeah, this one's at the bottom. So if I had them all set to, like this one, if I had them all set to go home, they all go back to the top, and it doesn't work so well. So here I have them actually get the position of T2, which would be the center, as it worked out in this scenario. And then I tell them all to go to that position, which would be the proper point in the coaster. And then I set their heading to 180, so that would be looking west, because if they're going clockwise, the way I have them drawing my coasters, they're drawing it clockwise from the top. And so this way they're heading at 6 o'clock would be west, which as far as the turtle is concerned is a straight line. And same for turtle 1 and turtle 2. And then here in the for loop, I mimic that. Instead of go home, they go to the XY position, and they have their heading set west, technically. And then the counter, again, is over here. Except this time I didn't need the plus 90. just worked out that way because of their heading, their starting position. Okay, so design P23. So this one needed a bit more math. I ended up, you'll notice this piece function. What this piece refers to is I took this square, and then the piece is this added bit right here that juts out a little bit. So it'll be this, that, that, and that. So the width of that is the piece function. That's what this is saying. This is piece is equal to this width. So from the top, from there to there, straight line going down, and the width of that between the corner right here and between this corner. So the width of that white. Yeah, so the easiest way to understand it is the width of this white portion, which would be equal to the width over here. And that's just to make calculations work. And so that's what this piece is that keeps reoccurring. So let's start with weird square probably right here. So we'll start here. So this is weird square, I called it. Didn't really know what else, a better name for it. Gave it a dark outline for the grout in the design page, and lighter gray for the fill. Let's see here. Yeah, so I set the position as ZT. That's a helper function. So I set it to go over here, start drawing. Yeah. Yeah, so what I do is I set it over here in this corner, right down here. And I have it draw angle weird square, which is this. So it goes up at a 45-degree angle, goes like this, like this, like this, and then goes back to the center, because I have it starting in the center. And then what it does is from there, it moves. So row 1 sets a position, weird square, and then it moves. And the move function brings it over here, brings it here, then back up here, and then draws this, brings it back to the center, then brings the turtle back up here and draws this. And then I set it up for 2 rows again because I didn't feel it was necessary to make the actual design scalable to an arbitrary number of rows and columns. And so simply it just draws row 1, and then a helper function next row brings it down to here, draws this, next row, row 2 right here, which is just the opposite of row 1. And then goes here, and then brings it back to the center here, brings it back up here, and draws all of that, and finishes out, I believe, right there. No, finishes out right here in the center. And so it's that design. This one was pretty straightforward, I thought. I didn't really have much trouble with this one. Really, P23 and P12, the triangle design, were very straightforward. It was P37 that gave me a little bit of trouble, but persevered. Okay, this is the invert color for P12. I didn't have to write any particular code for this one, the inverse color. In the final, I'll just go down here and show you really quick. Where are you? Yeah, so here it is. This was the normal P12, and then for the inverse color, it was pretty easy to just put in the different colors down here. It didn't really work out too well with the other functions just because of the way I'd written it. And by the time I got down here, if I wanted to make the colors invert down here, it would have been, I would have had to rewrite a lot of code up here, and it just didn't seem like it would have worked too well, because then this code wouldn't work, and then it would be back and forth and just a big mess. So I decided to brute force my way through some portions down here on drawing the final coaster. So that's why you don't see a P12 inverse color. So anyway, let's see, P37 invert color. I believe we already went through this. P23 invert color. Also pretty straightforward. I copied a lot of the functions and I gave them a subheading of A, just so it's easier to differentiate later. And I just changed up some values, like just the colors, essentially. That's all it was. Just reverse the colors. And I decided to keep the colors, in this case, inside the function rather than making a variable, because I felt it was unnecessary to give it a variable for arbitrary colors, just because we had to follow designs. So it seemed like it was easier than having to have like 5 or 6 or whatever different variables in each one of these things. Made it less understandable, I thought. So this way it's just, you have a size and a turtle, and then everything else you need to know about what's going on is in the actual code. It's just easier for me to understand it as I go through it, I think. Anyway. So, instead of probably show the final coaster, and then we'll go over how my strategy for how I put it together. So here's the final design. I guess before I go into it, there's some elements here that are peeking out. I had some trouble with this design, formatting it. You can tell there's some formatting issues there and right there, and I'll explain what that little pink element there is in a minute. I realized a little bit ago that I could have started the turtle in the center and had him draw design, come back, but I was already too far into the project at that point and didn't really have much time left to edit it, so I decided to keep it this way and just play around with the code I had to format it a little better, which is where the brute force came in, rather than start from scratch. But this design gave me a little trouble because I set the size to this length right here of 1 square, whereas the size here is this length, and trying to get these two to equal each other needed some playing around. I realized at a certain point that essentially if I set this one to 2/3 of the size of this, that would make them just about equal, just because here there's 3 quadrants with size and here there's 2, so it seemed natural to me to set this to 2/3 as a proportion. This one didn't really have much issue. It's just the fact that this design exists that gave me some issue with some formatting here, different things. I also had a little trouble getting these triangles perfectly even, so I kind of cheated a little bit, and I'll show you what I mean by that in a second here on the PowerPoint. So yeah, this is the final design. So here's the P37, what would this be? This is P23 and this is P12. And then here's the inverse of P37, inverse of P23, and inverse of P12. I could not for the life of me figure out why this triangle is actually outside of the border, when the way I have the program written is that it's actually the fill, and the pen size doesn't change, because here you can see that's not an issue, technically, because this is the inverse. This right here would be this triangle, and it's the same exact code, just the colors changed, so I could not figure out why that is the case. How this comes out a little bit outside the border and this is inside, because this triangle is not a separate element. This triangle is the fill of that border line that should be right there. So I don't know why that's happening, but it seems to be. And again, this is also the borders here. They're I set them to 0.02 times the size right here of this triangle, just so you could scale it, because otherwise it was either too thick or too thin. But this way I think the proportion of the border to the triangle and the overall shape looks a little more, a little more pleasing. It's not ugly. Anyway, so this is the final shape. Let's see how I got to this here. So I was should probably bring that shape back up actually. Let's bring it up. It'll be easier to talk about it. Okay. So I'll just do that. And also the scrolling made life easy by setting the window to 4000 by 4000. You can see the whole shape. So first what I did when I first put this coaster together was I did all of this. I drew the shapes, and then I drew the triangles, and then I drew a hexagon inside to do the inner fill, and it just did not did not look too great. There was some formatting issues. There was a bunch of white empty spaces. So I figured what I could do is kind of like in Photoshop, I could build it in layers. So I decided to make the bottom layer the inner fill right here, just a circle. And I did negative 3 times the size. So just to give it some sort of ratio to work with of the final function. So I did negative because otherwise the turtle was drawing it like this, but I needed it to draw like this because my first shape is up here, as my code was written, and I decided to do this after I finished writing all the code. So negative 3 times the size, drew a circle exactly how I wanted it, this way, going around clockwise, and also just the right size for what I wanted to do. That's what this pink element is actually, right here, because the shape is, for example, this shape right here, this design, the center of it would be at the very top of the circle. And so that's why this element comes out. It's because I couldn't really get that side hidden just because of the way the design is, I think. I could have made it white, but then this wouldn't work, and then it would just be a white empty space over here, and it would just look weird. So I decided to leave it and just let it be in this case, just because of the way the design is. So that was the first element I decided to put down, and then everything else goes on top of that. So the next thing I did was I put these triangle fills on top. I put them right on top of the circle inner fill. And what I did was I actually just kind of kept it simple. I programmed. I'll show you the code. So here's the helper function for the actual triangle. Equal triangles, so 60-degree angles, so turn right 120, begin fill, end fill. Pretty easy. I decided to brute force my way through this also. Yeah. I have this piece in here again because of that design, the P23 with the weird angle and the weird square. It was just that weird square, as I call it, was giving me a lot of trouble with formatting just because of the way it's designed. So I had to incorporate this piece calculation into a lot of the final coaster design functions, just to keep myself sane, I guess. And there's, you can see a bit of brute force going on here, but it all scales. I mean, it's just, there's going to be some elements popping out here and there, but they all pop out the same in each size. So like, if you set the size to 50 or 200, you'll still see the same elements. Nothing changes. So, but yeah, there's some brute force going on here for sure. Anyway, so I pretty much did 3 equal triangles. So 1, 2, 3. And then what I did was, this is the outer ring. I call this the outer ring, just these triangles. And here you can see I did the half coaster trifills, which is this. So this is the half coaster triangle fills. And then here, this number. I don't actually have the code for how I got this number because I just kind of did it as I was going and then deleted the code since it was unnecessary. But what I did was I got the turtle to draw the designs that I programmed, which I did first, which was where is it? Outer ring. So where'd outer ring go? Well, this is draw coaster outer. Oh, outer ring. Here we go. Oh, this is outer ring. Wait. Oh, draw coaster outer. Sorry. Yeah. So draw coaster outer. There was also some brute force going on here. But see, this right here is 2/3 of the size. This is P23, the weird design, minus the piece, again because that weird piece jutting out. And because of this, I had to. This is really the reason right here. I had to brute force my way through it. I tried different things and I couldn't figure out exactly how to. This is the best I could come up with essentially. Otherwise, all the other designs are just SZT, not really much brute force going on there. It's just this P23 that kind of got in the way of things. And then this is actually unnecessary. I edited my code earlier, and this is old element. Needs to go away. It doesn't do anything. Okay. So how I got this number here. So as I was drawing this, when I got to P37A, before P37A starts, the turtle is directly in the center here, and seen as this is there's symmetry here between these two sides. What I realized I could do is I could get the coordinates of this spot here, and then I could just repeat this half this way, which is exactly what happens here. So I got this coordinate as my x, and then the y coordinate, I got an actual coordinate, but I decided to divide it by the size of that point to get this constant, and it worked out pretty well. So this is the ratio of between here and here dependent on size. So whatever I set the size to, this actually scales beautifully. I was surprised myself that it worked as well as it did, but whatever I set the size to, it multiplies it by this constant, and the turtle always ends up exactly in the center right here. So that worked out really well. I was pretty happy with how that worked. And then here I set the heading to 180, again because if I bring it down here, the turtle will head this way. It's not what I want. The turtle is supposed to go clockwise, so it goes like this, and then it should continue going this way. So that's the equivalent of bringing the turtle down here and rotating it 180 to face that way. And that is what that is. And then pen down, and then half coaster trifills again, same exact thing, going this way. So, in other words, the way this code is written, this triangle is equal to this one's equal to this one, and this one's equal to this one. And then the draw coaster outer, that would just be the outer ring. So that's this ring. And originally what I did is I drew this first, then I drew these triangles, and then I did an inner fill, but not the circle. It was just a hexagon, or yeah. So, but then I reversed my order and I did this, then I did this, and then I did this, and I'll show that in the final bit here. So yeah, so start at the center of the first design right here, draw this, and then brute force my way over here. That's why it's a bit off center, and actually brute force my way up there and draw this. Finishes out, brute force my way there, draw this. This really didn't actually need any brute forcing to get to this corner because the the turtle ends right there anyway, so that worked out really well. But I had to bring my turtle back here. At this point, I got these coordinates here when I was doing my early stages of designing this, and that's where I got this fancy number from. But either way, that's beside the point. And then you'll draw this, this. And again, here's that, I don't know why it's doing that. I really couldn't figure it out. It makes no sense. It shouldn't do this at all, but it is. Yeah, and piece shows up again in the outer ring just because of this right here. This piece, need to figure it out. And so my idea was, by doing it in reverse order, by drawing this, then this, then this, I could put these shapes on top of these triangles, which are on top of this, and that way they could hide some of the offsets that exist because of the brute forcing I did, and it would look a little more well put together. So I guess just go here, and this is the top level function. This is what does everything. It's the final thing. So, and it's simple. There's just two variables, size and turtle. It does everything else. It's all in the code. Here you could see I start with inner fill. So I have the turtle start here, draws a circle like this, then goes home, back in the center, just to keep things as even as possible. Then do the outer ring, which is these triangles. And then again, turtle.home, right back there in the center. And then draw coaster outer, which is these 6 designs. And here I have it set to a size of 100. I set it to a size of, I'll set it to a size of 100 here too, just to keep it all the same. And here let's do, should have just commented out that before. Bear with me here. So here we'll get the get some drawing action. Oh. So, oh, sorry. There we go. There it is, drawing it. And so you can see how over here, I have it going on top of the triangle. I have this element popping out over here. And this is again on top of the triangle. So with the bigger size, you definitely see some of the formatting issues I've been having here. Tried to work on. And here the triangle looks like it works normally. So happy about that. Yeah, here's the final design. I'm sure I could go back to it if I had more time and really perfect it, but I think that would require a big overhaul of a lot of portions of the code. Particularly if I could go back, I'd like to rethink my strategy for this design, and also if I could go back, I'd probably redo how the turtle gets to these positions. Probably start the turtle out here in the center, and I'd have it go, because that way it's pretty easy. It's 360 degrees, there's 6 designs, so there's 60 degrees here, 60 degrees there, 60 degrees there, 60 there, 60 there, 60, which essentially would make this all equilateral triangles. So that'd be very easy, and I could just do the fill. I wouldn't have to do this inner fill, and I could go here and start here and draw this shape, come back home, go here. Wouldn't really need any brute force or formatting, would I? Just draw this shape here, and again do that. And then for triangles would be the same. I would just go back there and do a little turn, 30 degrees, draw it back, and again. So yeah, there's definitely a lot of ways that this can be improved that I would love to do if I had the time again. But for now, this is what I've got. And let's see, is that it? I believe that is it.